Okay, part B to the horse barn free response question. This is a pretty tricky algorithm, right? The idea isn't too hard to imagine, right? We've got a horse barn and we want to consolidate. So we have an array of horses and we want to consolidate them so that we kind of shift them down so all the empty spots are at the end. So, you can imagine we want to feed them all, so it's easier if they're all down at the end. So basically, we're going to take and move Silver over here, and then Patches is going to move down here, and then Duke would move down into the third spot there. I guess the technically fourth spot, but third index down there, right? So that it looks like this at the end of the consolidate method, right? So we can't like make a new array or anything like that. I think we have to use the array that is kind of the global array. So yeah, where the heck is it? Lost that. So we are inside of um, this horse barn class. So we're going to consolidate this array. So we're not going to make a new one or anything like that, even though I thought of a bunch of ways where you could actually do it that way. But we want to just change that one, keep the order the same. All right, so after the consolidate part, the order should still be the same where Trigger, Silver, Patches, Duke, they just been smushed down here. Right, so the first way I thought to do this actually was to make like an array list and then just pull out every single one that isn't null, then go through and check the array, make everything null, and then go back in the array list and put them back in one at a time into the original array, which I don't think is a terrible strategy. It's probably not that efficient and maybe a lot of code. Certainly that would be a route to do it. After I thought about it some more, I thought kind of what an easier route to be is, I'm going to try and demo it here, is to make two loops. Okay, and so the outer loop I would go down each spot and attempt to fill it with any horse that's to the right of it. So basically, if we hit one that's null, try and fill it with a horse to the right. Okay, and I don't think we'd actually have to go all the way to 6 because there'd be no horses to the right of 6. But at any rate, I would go down and say, I'll have another index for the second loop here, but I would say, okay, is this one null? Nope. So we don't need to fill it. So we'd go down here and then say, okay, this one is null. So J would start, the inner loop would start at one more than I. And this inner loop would say, okay, if this Jth spot, if that's not null, I'm going to put it here. So basically we would send this one over here, copy it over, and then this one would now become null because Silver is no longer in there. So I'm going to put the null over here. It's kind of like swapping, but not really, because you can just set position I to be position J, and then set position J to be null. Okay, and so then we need to make sure the inner loop ends because we don't want it to keep going then, right? Once we found a horse for spot 1, we want to say, okay, now we're going to go to the outer loop again, send I over 1, and say, okay, is this one null? Yep, so now let's have J start after that and look for one that's not null. So it would go down all the way to the end, or when it finds a non-null one, say, okay, now I found a non-null one. So Patches is going to get copied into the I spot. And then we just need to set the spot where Patches was, the J spot, to be null. And again, we want the loop to end there, the inner loop to end. So that's kind of the trickiest part, is you have to make the inner loop break at that point. All right, so at any rate, the inner loop would break, so J is out of the picture now. I would increase by 1 and say, okay, we got another spot we're trying to fill. Start with 1 to the right of I plus 1. Go across until we find one that's not null. Okay, and then Duke gets slid into the I spot. The J spot becomes null. Okay, and even though we can see that we're done now, the algorithm wouldn't know. We'd have to check here. Then we check, okay, is there one that's not null? And nope, it would just get to the end. And then it would, then I guess you could be done, right? If you made it all the way to the end, you could be done. Otherwise, maybe the code would just keep going and keep checking. And if it's a null spot and they can't find a horse to fill it, then it just keeps moving I over by 1. All right, so now we just got to do that in code, and we're going to need 2 loops for this. All right, the other weird thing about consolidate is we don't have anything to return, and we don't have anything coming in because we're just using the spaces array. Okay, so the first one is going to be a for loop very much like part A that loops through all of them. Even though technically I think we could do length minus 1 here because we don't need to do the last spot. Right? We don't have to check because there's nothing to the right of the last spot, so we wouldn't really need to do that last spot. But if you want to keep it spaces, it'd probably still be okay. Spaces that way. All right, then I'm going to do for int j, which is going to start looking 1 to the right of I, so I plus 1. And I'm going to keep looking all the way till the end again, plus plus j. Okay, and actually I should do this first. So if I only want to look if it's null. So I'm going to say if spaces the ice spot we're on equals null, then we need to look, right? So in this example, for space 0, we don't try and fill space 0 because it's already filled. So for the I loop, we should say, well, if it's not null, then we want to search down. So I'm going to put all this inside of that if. Okay, and as we search, so basically we want to try and find one that the J spot that has a horse. So we're going to do something like this to say, okay, so now we're searching for a not null space, 1 to the right of the space we're on. So if spaces J is not null, that means we have a horse in there, okay, which is good. So now we have to copy. So if we do this visually again, see if I can do this, move this back a second. All right, so what we need to do here is we need to make spot I be spot J. So we're going to put that there. All right, so we're going to have spaces position I becomes spaces position J. And we don't need a temp variable here to swap because once we do that, once we move Duke into this spot, then we can just check, make the J spot be, like technically J would still have Duke at this point, but we just put null and then it's overwritten with what we want. Right, so we can now say then the J spot should become null. All right, and then to me this is the hardest part is now we have to we want this inner loop to break. Right, we don't want to keep searching once we found a space for this horse. Right, because we might have another non-null space and then we run this code again. So to break the inner loop, I think you could type just break would work, but I would, to be safe, I just force it to break. So we know it stops when J, it keeps going as long as J is less than spaces.length. So if you make J equal to spaces.length, that'll just force it to break. Okay, and then J will get reset, right? Once we go to the outer loop again, we'll get a new J that always starts one more than I. And we just break the inner loop at this point. Right, and I believe that's it. We don't have to return anything. This just checks for a horse there, and if it finds one, it replaces it, and then it'll keep looping. I will to each spot, right? I is going to loop through each spot looking to find a non-null horse to the right of it. Right, and I think that's probably the easiest way to do this one. That's, again, there's other algorithms, but yeah, that would be one idea. If you want to check if your answer is right, just submit your code to me. I made a little test case here to run it. That took a little work because these aren't static methods and stuff. But at any rate, if you want to know if yours is okay, just let me know. All right, thanks.